Hi everyone. Today we're going to discuss about simultaneous equation. So under simultaneous equation, we have three different methods. There is a substitution method, there is the elimination method, and there is the tree diagram method, which I believe we're not going to discuss today. I'm just going to discuss about just the substitution, and also in the next video you'll see is the elimination method. Those are the two methods that I believe is the best to solve this equation. So let's see how this is done. Okay, so first of all, let's look at the equation. So if you see this equation here, we have 2x plus y equals to 4 and x squared minus 2xy equals to 3. So based on these two equations, to make our discussion easier, I'm going to label this as equation 1 and equation 2. So based on these two equations here, let's look at which equation is the most easiest or the most simple equation in comparison. So based on these two, I feel like equation 1 is simple. Equation 2 is a bit of a complex equation because we have a square here and two different variables here or two different unknowns. But in equation 1, there is no squares, all are under linear, and it's quite simple and quite direct. So why I'm saying this, why is this method important? Okay, so the first step is let's look at 2x plus y equals to 4. So if I were to substitute just x alone here, I'll be looking at two different substitution. Whereas if I just substitute y, I can only substitute once. So with that said, I'm going to take equation 1. So here we go, from 1. So from equation 1 here, we have 2x plus y equals to 4. So when 2x plus y equals to 4, y is the subject, hence 4 minus 2x. This is basic algebra. I suppose you should know that. So this is equation 3. Okay, so from equation 3 here, what we're going to do is we're going to substitute, okay? 3 into 2. So 3 into 2 meaning when we see equation 2 here, let me use a different color. We can see equation 2 here, we'll see is x squared minus 2x, and hence y now is being substituted with equation 3, which is 4 minus 2x equals to 3. Hence, x squared minus 2x here, we can expand the bracket. We'll see is 8x and then plus 4x squared equals to 3. Now what we're going to do is we're going to make it into a quadratic equation where 4x squared, meaning we just rearrange them, plus x squared minus 8x minus 3 equals to 0. So from here, what we are looking at is just 5x squared minus 8x minus 3 equals to 0. So with that said, just using a calculator, I believe I'm not going to discuss here about factorization. By just using the calculator here, where a is 5, b is negative 8, and c is negative 3, we'll get an x value of x is equals to 1.9136, and this is x1, and x2 would be negative 0.3136. I'm putting into 4 significant figures here because it's much more easier, and usually this is what is demanded by the exams. Okay, so hence we got 2 of these values, and based on these 2 values, we can find the y accordingly. So what is y? Okay, y as we know it, okay, let me change color again. Y as we know it is 4 minus 2x, 4 minus 2x, and when x1 is equals to, okay, so 1.9136, and x2 is equals to negative 0.3136, okay, so let's see what is y1. So y1 would be 4 minus 2 times x1's value, 1.36 is such a easy calculation where you can just type in your calculator 1.9136. Okay, and then we will get a value of 0.1728. Okay, and then y2 would be 4 minus 2 negative 0.31, sorry, 3136, and we'll get 4.6272. Okay, so this is the answer. Okay, as you can see here, we have our x value, x1, x2, y1, and y2. So we have solved this equation, and in the next video, I believe I will explain to you on how we're going to solve the similar question in elimination method. Okay, so usually substitution method is the most famous method by everyone because it's quite easy and quite direct for everyone to do, whereas elimination method, it's a bit subjective and it needs a bit of a technical knowledge, where I'll explain to you next in the next video. Okay, so by then, see you guys, see you on the next video. Thank you very much, and please subscribe. Okay, bye bye.